that you may have forgotten that. That's from chapter 4. Hopefully, that's one of the things that you guys kept was your vocab sheet. It was blue from chapter 4. It looks like this. That would be one of the things that I would have kept from this class. Okay, anyway, regardless of that, I found a diagram that will help us remember what matched pairs is that I want to show you. Hold on. Okay. So this is back from chapter 4. This is the diagram that I like. It has some participants out there in different colors. Matched pairs. The first step is it matches each with its closest partner. And if you guys remember, a lot of times the closest partner was itself. So matched pairs was the one where you did the left hand and then you did the right hand and then they subtracted. So matching you up with two pieces of data, sometimes you're just matching up very light things. In this particular, if you read the example that we cut out for today's arts and crafts, it's about twins. So it's often twins in matched pairs for obvious reasons. Anyway, and then the second step is one participant gets randomly assigned or randomly selected. It doesn't have to be an experiment. And then the other one is automatically the other group. And what they do is they take some kind of statistic, an average of something, height, weight, something, I don't know. And then they usually subtract it and find a difference. Okay, so the math is actually easier when it's paired. But you guys need to just be able to tell which is its own skill. Okay. So we're going to write ourselves just a little reminder about what paired data is first. It results from recording two values of the same statistic, meaning mean, proportion, height, weight, anything, for each individual or one value for similar individuals. Okay, so let's go over this again. Results from recording two values of the same statistic for each individual. That was when you did the left hand reaction time and the right hand reaction time and we subtracted. Or you could have one value from similar individuals, the height of one twin and the height of another twin, something like that. Doesn't have to be the same person each time. They just kind of have to pair up. Okay, now, Mrs. Talbot, I'm really confused now. I'm pretending I'm you because there's two groups for some of these and you put one sample t-interval. Why is it sometimes two groups, but you put one sample? That's because the differences end up being the values you use for your sample. So the subtracted numbers. So the one sample comes from after subtracting. And which is great because then that means we get to do the easier math. Okay. This reads, hold on. Okay. All right. This reads one sample t-interval for mu d. This is mean difference. The little d stands for difference. And I really want to make sure that you see the difference, between mu d and mu1 minus mu2. Okay, these are two completely separate independent samples. And these ones are paired up, and you're going to end up with just one set of numbers. There's two sets of numbers. It's going to be one set of numbers after you subtract. Okay, so just have to keep your eye out for which is which. Okay, anyway, the state. How do you think we start it? It's not going to be rocket surgery. Yep, perfect. Blank percent confidence interval for mu d equals the true mean difference of blank, and that's going to be your context. Probably your two things that you're subtracting in the problem. Okay, however, in this one, you need to make sure that you put a subtraction order in the state. So if you look down at the your cut and paste problem, there's twin A and twin B. So at this point is where we will make sure that we establish the order A minus B or B minus A or whatever. Okay, plan. One sample. I don't know why I put a dash there. I don't really want a dash there. One sample. T interval for mu D. Random. Same as usual. Just look for the wording. 10%. Same as usual. Just look for the wording. Do we need to go over these? Okay. We do have something to say about large counts. N is greater than or equal to 30. So CLT applies. Or if N is less than 30, what do we do? Yeah, okay. Now this is the very important thing. Or if N is less than 30, check the dot plot of the differences. It has to be the differences because that ends up being your one sample. So after you subtract. Okay. Do this, we follow the one sample, not the two samples. So you're going to have X bar of the differences. You're going to have T star. And you're going to have standard error of the differences. If this is confusing for you, it's okay. It's really going to make sense after we do the example, I promise. And then you have your statistic plus or minus T star times standard error. Okay, after you get that, go ahead and tape your stuff in the notebook, paste, copy, cut, whatever.
Oh, no, it's got them. Yeah, season tape better.
Guys, real quick, while you're arts and crafts after you get your problem put in your notebook, in your group, I want you to subtract the columns that very specifically says A minus B here, so you're gonna do top minus bottom, so 8 would go in this box. Do you understand? This box would be 8. Hello?
Yeah.
Okay, you're gonna fill in all of those. Then, you're going to grab a graphing calculator, and you're gonna put the difference line into L1. And you're going to run one variable step and get the mean and sample standard deviation. Does anyone else see Disney XD whenever you see X bar D? No, no. No, just me, that's fine. Okay, if you're talking about why tape is superior to glue stick, that does not count for this particular problem.
You're good, bro.
It's just hard to write on the tape.
You got it, Dave. You got it. Take your time. Let me go ahead.
5.83.
What are we talking about? Like, what are we talking about? So funny about that.
Point and 3.9. Okay.
No. Okay, was that
All right, there's your spoiler if you're ready. The mean is 5.83. Sample standard deviation is 3.927. Any questions about how I got any of those things? You good? You sure? Why does that sound sarcastic?
No, because I was letting you know.
Okay, this is really, really sad, but data from a random sample of identical twins are shown in the following table. Construct and interpret a 95% confidence interval for the true mean difference in IQ scores among twins raised in high versus low income households. So for this study to be possible, they had to break up identical twins and have one of them live in a high income household and one live in a low income household. This is not, well, it wasn't, this is actually a random sample, which means that it was just data that was collected. That was not this study that forced this to happen. It's just that life forced this to happen. And so anyway, okay, state. Still sad though. Makes me sad. Okay, 95% confidence interval. For mu d equals the true mean difference. Okay, and then I'm gonna go up to the problem and start copying off of it. True mean difference in IQ scores. Among twins. Raised in high versus low income households. And then I'm going to put the order. So it tells me the difference A minus B. So I'm going to put I minus. You think it's weird that like living in a high versus a low income household could actually affect someone's IQ? Anyway, sorry. I just find this kind of stuff fascinating. So one sample T interval for mu D. Random. Yes, random sample. %. N equals 12 is less than % of all pairs of identical twins. Okay, and then I'm going to do large counts on the other side on purpose. you guys know why I'm gonna do large counts on the other side on purpose? Yeah, dot plot. Okay, but what of this information am I going to do the dot plot of? The difference line, yeah. Great job. Great job. Okay, so in my dots, the lowest is -1 and the highest is 12. I don't know if this is right, but why am I doing that? Why am I doing that? Three, 4, 6, 7, 8, 9, 10. Thank goodness I have last year's notebook here so I can look at the table. Eight, 5, 9, 6, 5, 8, 1, 6. -1, 10, 1, 12. Okay. What? What that? It was that? Good, okay. How does this dot plot look to you? Good enough, does it matter? No. No extreme. You know how the iPhone update has that new thing where you can like send the messages with the font that goes like, yeah, that's how extreme should look in your head. You know what I'm talking about? Yeah. Like extreme. Yeah, yeah. Oh, really? And you're like, oh, I know all of this. Okay. X bar D, we already got that from the calculator. That was 5.83. T star. Degrees of freedom in this problem is 11. Beautiful. Please still be in there. Please still be in there. Please still be. Yes. negative 2.2, so positive 2.2. What was it? 3.927? Do you guys know where these numbers came from?
Yeah, that was a fair deviation and the end.
Beautiful.
Well, no, no, no.
So statistic plus or minus critical value times standard error. Okay, we have two more things to do. Three more things to do. We need to finish this. I want to put one sample T interval from UD on our yellow sheet in the right standard error spot. And then I want to show you the joke, which has Dr. Zoidberg in it. If you don't know who Dr. Zoidberg is, well, yes, dear.
We do have convincing evidence because of possible.
Indeed.
Yeah, she's good.
Yeah.
Oh my God, man, that was good.
I was around that.
Okay, but the results of this are so sad to me. Do you understand what this is saying?
That is true.
That's true.
That,
He was higher.
yeah, for up from 3 to 8 points higher for twins raised in a higher income household. It's so sad. Well, I'm not a researcher. Anyway, okay. Okay. There's my conclusion. That's the end of chapter 10. I need you to get your yellow sheet out, please. Okay. So we still use this. We wrote one sample T interval for mu, but we also use the same one for the one sample T interval for mu D. You can put it wherever you want. I'm going to put it here. Or you can just say any kind of one sample T interval. But this is basically clearly the one sample location, and then this is the two sample location. Okay, so from now on, you're gonna have to keep your eye out for paired versus independent samples. And if it's independent samples, you're gonna use this, and if they're paired, you're gonna use that. And I'm going to write problems in the team test and things that get you to think about which is which, so that'll be good. Okay, now let me show you my joke about Dr. Zoidberg. Okay, here it is. Homework is 37 to 47 odd, 49 to 52. By the way, not due Thursday, due Friday. Remember, if you have a test, so you should study first, then do the homework. It says your sample sizes are small, your standard deviations are high, your conclusion means nothing, and you should feel bad. Look at how mean he is, Miss Dr. Zoidberg. Yeah. Hopefully he doesn't come to your AP research presentation and heckle you from the audience. That would be scary. If you see a squid looking guy in a tuxedo coming in, you might wanna, postpone.
Wait, what did you mean?
Dr. Zoidberg, do you want the yellow sheet, you're saying? No, the notes?